All right, this is my second time trying to do finding zeros of polynomials given a factor. As you can see, I've already worked out everything, but I'm going to explain it a little bit. So for this first one, we have x cubed equals 9x. What I had to do was bring the 9x over, so that's why I subtracted it. And then I had to factor out the x, and then I could set x equal to 0 and x squared minus 9 equal to 0. And you can see I added 9 to both sides, and then I had to take the square root to find plus or minus 3. So my three answers were 0, 3, and negative 3. If you look at number 2, you can see all I did to start off was I added 16 to both sides. And now I have 4 terms, which means I need to factor by grouping. And so the first 2 terms, they have a 2x squared in common. So I take that out, and I have x plus 4 left over. So I'm looking for another x plus 4 on the second 2 terms, which I have. I can take out a 4, and so I have 4 times x plus 4. And so then I combine 2x squared plus 4, and then the x plus 4 stays equal to 0. So when x plus 4 equals 0, x equals negative 4. When 2x squared plus 4 equals 0, I end up getting something squared equal to a negative. And so that's not possible unless we're dealing with imaginary numbers, which in this case we are not. So you can see I crossed that option out. Now for the next 4, I'm given a polynomial and one of its zeros or factors, and I have to find all the zeros. So now, if you notice in number 3, yesterday we always were given a factor. Now I'm given a 0. So when I'm given the 0 like x equals negative 3, instead of switching the sign, I keep the sign the same. And so it's a negative 3 out front, and then 1, negative 2, negative 21, and negative 18. And everybody seemed pretty confident with synthetic division, so you can see how we worked it out. We dropped the 1 and then multiplied through, multiplying and adding, and we have no remainder left over. So we did it right. And so we have x squared minus 5x minus 6 equal to 0. We have to factor it out. So just like we did before, we factored out a times c is negative 6. The two numbers that multiply by negative 6 and add up to negative 5 are negative 6 and 1. And so those are my 2 factors. And the extra step we have to make is set each of those equal to 0. So when x minus 6 equals 0, x equals 6. When x plus 1 equals 0, x is negative 1. And then I also have to include what was given to me, x equals negative 3. So I had 3 total solutions on that one. When I move to number 4, now I'm given a factor again. So I put the negative 1 out front, and I work through my synthetic division. That you can see we have no remainder. And so I have 2x squared plus 7x plus 6, and it's all equal to 0. Now I factor a times c, once again is 2 times 6, which is 12. The 2 numbers though that multiply by 12 and add up to 7 are 4 and 3. And so whenever I have a polynomial that has a value, a coefficient that's not 1 in front of the x squared term, I like to do grouping. So I make it 2x squared plus 4x plus 3x plus 6. And then I just group it, and you can see I end up getting 2x plus 3 and x plus 2, and I bring down that x plus 1, and I set each of those individually equal to 0, and you can see my answers. X equals negative 3 halves, negative 2, and negative 1. On number 5, once again, we're given the 0 of x equals 10, so I just keep that. And I go through my synthetic division, and I end up with 4x squared plus 15x minus 4. Now, this is one we haven't really seen before. So a times c is negative 16, and we have to decide what 2 numbers multiply to be negative 16 and add up to 15. Well, that would be 16 and negative 1, and you can see how I put those in there, 16x and negative 1x, when we're doing grouping. So the first group I take out a 4x, and I'm left with an x plus 4, and now I have a negative x and a negative 4, and I need to get an x plus 4 left over. So I take out a negative 1, and I have an x plus 4 left over, and so now I can combine and get my answers. 4x minus 1 equals 0, so that means x is going to equal 1/4. When x plus 4 equals 0, x equals negative 4, and then we also have the x equals 10. And finally, our last one is another one where we're given a factor, so we have to switch the sign. We get x squared plus 6x plus 5. That easily factors out to x plus 1 times x plus 5. And then I bring down the x minus 2, set it all equals 0, and my solutions for each individual one would be negative 1, negative 5, and 2. And that is our solving or finding zeros of a polynomial given a factor or a zero. Thank you.